Hello there, George with Minuttia and both of us here. And in this video, I would like to share with you, I would like to walk you through our internal linking tool and, show you around, explain the basics, and also share some general thoughts on the future of not just internal linking, but in general, what we do, many of the things that we do, and the use cases that will come up on the basis of, AI and all the great developments that happen on that end. So let me begin by saying that to be able to do and actually to use our internal linking tool and to do what I'm about to share with you, you will have to have access to 3 tools. The first 2 are paid, and one of them, you can use for free. I think so. But for a lower limit, and that's Screaming Frog. So these 3 tools are Screaming Frog, which is where we will basically start our process. Then you need to have access to OpenAI and more specifically OpenAI's API. And last but not least, you need to have access to a keyword data provider such as SEMrush or Ahrefs. To be able to get keyword data for the URLs that you're interested in. Your website, that could be your website, your blog, a specific section on your website, and so on. Okay, so assuming we have this, the first step you need to take is to do a crawl with the help of Screaming Frog of the website or the section of a website that you're interested in analyzing, right? And obviously we are talking about internal linking, so I'm assuming that what you want to achieve is to identify internal linking opportunities, once again, either on the whole website or a certain section of that website. And so the first input that we have and we need to have before we even get to the process I'm about to share with you next on Google Colab is to have this Screaming Frog export. And what we are interested in more specifically is this column over here, which is ChatGPT Embeddings, okay? And so in a previous video, we described and we shared the fact that the latest version and update of Screaming Frog allows you to extract vector embeddings from different pages on the web, and you can do that in conjunction with OpenAI's API. Okay, obviously you can use other APIs, the one from Google, for example, or any other APIs that give you vector embeddings. But for the purposes and for the sake of this video presentation, we will be using OpenAI's API, and thus the embeddings that this API can feed us with can spit out for us. Okay, so we have that, and you will see that something that we encounter, which is, I think, in most cases, should that be an issue because most pages are not that big or that long. But you will see here that the specific model's maximum context length, that we are using and that we are calling the API, which is OpenAI's, once again, API, is, somewhere around 8,000 tokens, okay? And in this case, this piece was a bit bigger, longer than that, and thus we got an error, right? We were not able to generate or extract the vector embeddings for that specific page, which I would say once again is okay, and we only encountered that in just a handful of pages in the content inventory we are analyzing and using for the sake of this presentation, which is Minuttia's content inventory, which is a relatively small content inventory, but obviously it has some pieces of content that are a bit longer, right? But that shouldn't be an issue in most cases. So this is the first input that we need to have. And as you can see, we called it Minuttia Content Inventory. Obviously, where Minuttia, you can put the place of your the name of your brand or the name of your client, whomever you are conducting this analysis for. And so we have the URLs, and we have mapped most of these URLs to specific vector embeddings that we have extracted with the help of OpenAI's API through Screaming Frog. So this is the first step. This is the first step of the process. Then, as I discussed earlier, we need to have keyword data, and you can easily get that data from a keyword data provider like SEMrush or Ahrefs. And as you can see, the sheet here is fairly simple: keyword and current URL. Okay, as simple as that. Now, these are the two inputs that we need to have. And obviously, there will be some API calls in the Google Colab as well, but that's a bit further down the line. To begin with, as you can see, we are breaking down our sequence in steps, and each step has a title that's somehow descriptive of like what is it exactly that we are trying to achieve or to do in that step. So in the first couple of steps, for example, we have install necessary libraries and install any modules, import any modules or components that we may use further down the line. And let me just say that when you begin a process like this, it's not possible, or in most cases, it's not possible to know all the libraries you may need further down the line, or the modules you may have to use, and so on. So this is obviously version 2, 3.0, and so on. After doing the analysis and getting to that final step, we understood that these are all the libraries and modules we need to have, and so we place those in the first couple of steps. Then we start uploading our documents. We start with the Screaming Frog file, as you can see here, and we import that, upload that, and load it to our Google Colab. We process the embeddings in the Screaming Frog file, which, as I mentioned, are being pulled out of those pages with Screaming Frog's help by using OpenAI's API, right? Then we define scan functions, and we run scan search and serialize the index. We then upload one more file, the second input that we have, which is the organic keywords file, right? And we call that Minuttia Organic Keywords, where Minuttia, you can put the name of your brand or client or whomever you're conducting this research and analysis for. And then we want to get embeddings for our keywords as well using OpenAI's API. However, keep in mind that you need to make sure that you're using the same model as the one that's being used from Screaming Frog when calling the OpenAI API, right? Here you need to place your key, obviously. I'd like to say a couple of things about that. I would suggest that you generate new API keys for every project or for every user if you have a team who's using APIs for different use cases, just to be able to track things, right? And then when it comes to users and tracking things, the costs are, if we are talking about a website with a couple of thousands of pages, the costs are not prohibitive, right? It's not like they're going to break the bank. However, you might want to cap the API costs. For example, we have them capped at 100 USD per month, which is fine. And after you add that limit, you also want to come here and track things, right? More specifically, track the cost and also track the activity, like how many tokens, how many requests have you submitted, for which models specifically you've submitted these requests, how many tokens were generated, and so on and so forth. Okay, and for the sake of this video presentation, once again, I would say that you have to double check and make sure that the requests that you submit to the API are indeed the ones to the model that you're actually interested in. And once again, the calls that you make at that point should be to the same model as earlier, okay? Because otherwise, the vector embeddings generated earlier will not be able to match the vector embeddings, most likely will not be able to match the vector embeddings that were generated, at that step of the process, okay? So then we will save the keyword embeddings to a file. We will load the document embeddings, and we will, we have some more steps here. The steps that take the most time in terms of in the Google Colab, which is fine, I should say, is step number 1 when we install all the necessary libraries, and step 13 where we compute the Cosine Similarity. Okay, and this is step 13, by the way, is probably the most important step in this process, and the reason is because we have essentially, as I mentioned earlier, we have extracted or generated the vector embeddings for each page included in the content inventory we are analyzing, right? And these vector embeddings, if you take a look at them, let's take a look, in fact. Okay, so as you can see, they are just, just a series of numbers, okay? So to a regular person, that shouldn't mean anything at all, right? It's just a series of numbers separated by comma, doesn't mean anything. But, and here where things get interesting, with Cosine Similarity, we are essentially able to understand the relevance and how close the documents, which, in other words, the pages we have in our content inventory, how close they are semantically to each other, okay? And once again, we are able to do that because Cosine Similarity enables us and allows us to measure the distance, okay, and the similarity between each URL, okay, which is not the same as, me coming up with just the keywords that these pages are ranking for and say that, it seems that based on the keywords or any other factor, really, these pages seem to be, close to each other semantically. So we use essentially vector embeddings as the vehicle, or we use Cosine Similarity as the vehicle to understand the connection between the different pages, and we are only able to do that after having generated vector embeddings for each page. Okay, as I mentioned earlier, there will be some pages based on that process, right? We may be able to overcome that later on, that you will not be able to generate these vector embeddings for just because there is a context limit, but that's okay. I mean, we are talking about pages with a few thousands of words, which I would say in our days, that's an overkill in most cases, unless we are talking about a topic or a half page of a topic cluster and so on. So after you've computed Cosine Similarity, we get to the final step of the process, which is basically, okay, we've done all that. We got this export from Screaming Frog. We got this export from Ahrefs. We called OpenAI's API in that Google Colab. What's next, right? So what's next is to be able to get insights out of this process, right? And out of all the data that you have collected. For the record, let me just say that generating keyword embeddings in this case is not as important as generating vector embeddings for documents, aka pages, aka URLs, okay? Because essentially what we're doing here is that we are trying through Cosine Similarity to understand the relationship between pages, not between keywords and pages, or keywords between keywords itself, between one keyword and another keyword, right? Having said that, you would expect we sort of we started with some inputs, and then we need to finish this process with some outputs, right? And in our case, the output is one Excel spreadsheet that we are generating. And let me just take a step back here, or open a parenthesis and say that if you export the data in a CSV, for example, okay, without any filtering or without setting any like criteria or parameters as to what you want to see, what you will end up is something like that, okay? And remember that Minuttia's content inventory at the date of like this recording is relatively small, somewhere around 40, 50 pages, maybe a bit more than that. And we are talking about 182,000 rows here, okay? And obviously, you can see that there are duplicates here. We have pages that have a Cosine similarity of 1, which is basically, the same page, and so on and so forth, right? So if you don't set any criteria and parameters and filtering as to what you want to see, this is what you will end up with, okay? And yes, you can then filter the data and sort of get a better view over like what's really important and what I can actually use and take out of this process. And you can do that in Google Sheets with some formulas, right? And you can sort by Cosine similarity, which means which pages are closer to each other in plain English. Or you can sort things by URL, because you may want to see which URLs, all the opportunities that are out there for one single URL. Okay, and you can do that. However, we found it more efficient to be able to, do these computations and filtering and this cleanup here in Google Colab, so that we end up with something like this. Okay. So what you see here is we have two tabs. This is a Google, not a Google, but an Excel spreadsheet once again, and you can upload it in Google Drive and be able to, play with the data, right? So what you see here is we have two tabs, one of them sorted by Cosine similarity, the other sorted by URL. And we have URL 1, URL 2, and Cosine similarity in the first tab. And let's take a look at the data here, because this is where things get really interesting. And this is where, the power of vector embeddings and using Cosine similarity as a vehicle to understand the relationship between the pages kicks in and comes into play. So we have, I will just, use just a few examples. We have in the first, in the second row of our table, a piece that's called topical authority ratio, as you can see here from the URL, and one that's on topical authority, okay? And basically what we've built so far tells us that the similarity between these two pages is 0.95, roughly, okay? And this is spot on, because even from the URL, without even, getting on the page and like reading the piece, these two pieces, you can understand that topical authority ratio, these pages must have some of information overlap, right? And this is why this is so powerful, because imagine if you have to do that on a content inventory that's, 1,000 pages or 2,000 pages or, 10,000 pages. You can't possibly go and like check every page for similarity, right? And this, by the way, is not important just in the context of like finding, uncovering internal linking opportunities. It could also be important in the context of a content audit and a decluttering of the content of your content inventory. Because you may go and say that, wait a minute, we have 5 pages that seem to be having like overlapping information. Maybe we should take a better look at these pages through a manual review and eliminate some of those, cut them, like redirect them to one page and like work on that page to make it stronger. So this is why this is so powerful. And you can see here that in this tab that we've sorted by Cosine similarity, essentially by relevance between the different documents, aka pages of our content inventory, The second one, alternative keywords study, which is a study we did on alternative keywords, and the URL we have here with a 0.94 Cosine Similarity, comparison keyword study. Okay, topics vs keywords, topical authority, keyword mapping, keyword selection. All these are spot on. Roughly speaking, I would suggest that you take into account the opportunities that are, I would say, roughly speaking, above 0.85, right? And you may want to build links back to a page that's important to you for whatever reason, right? Then you need to use the second tab, which is this one, sorted by URL, and you may want to build links back to this page, algorithmic vs heuristic SEO. Okay, and you can see here, if we check pages by Cosine Similarity, we have 0.9 here. As you can see, one page algorithmic vs heuristic SEO, the other SEO strategy hurts brand. And I can tell you, because I know these pieces, because I think I was the one who wrote them, that there is some information overlap, and like we discuss similar concepts and we talk about like similar things, right? Another one, once again, yeah, your company doesn't always need SEO, right? And this one, another page now, again, alternative keyword study, comparison keyword study, 0.94, right? Let's pick another one from this. We have, that's almost, yeah, alternative keyword study, SEO competitor analysis. And this one that stands out, alternative keyword study, software keyword study, okay, which has a Cosine Similarity of 0.92. So that's it. That's the process. From there, obviously, you have to spot, the best anchor texts and find whether or not you could do so many things from here. Like you could bucket things into clusters and then try to interlink between the pages that belong to the same cluster and so on and so forth. But I would say that even though, as I mentioned earlier, there are so many use cases for this, really, and this goes far beyond just like internal linking. This is why we included the ability of generating vector embeddings for the keywords that you have visibility for, because you may want to expand this on this sequence that we have built and created. But even for internal linking, which is the main use case here, I would say that it's a far better way to spot these opportunities and at scale, right? Because we saw how like something raw would look like, and obviously we cleaned that up and we filtered that and we sorted that so that the output actually is easy for us to use, right? And so in general, I would say that this is a far better way and like way more advanced way than what most people and most companies do out there to identify internal linking opportunities. I hope you found that useful. Please, if you use that, drop us a note, let us know how it went. And obviously, we would like to hear your feedback and any ideas or use cases you may come up with that we have missed. Even though we constantly experiment with these things and try to identify new ways to add value and do things better and in a more scientific, if I could put it that way. That's all. Thank you very much and have a great day.